All right, for today's lesson, we're going to start our topic or our sections on trigonometry. Trigonometry is the study of right triangles or triangles and the unit circle. The most important thing, or the thing that will help you the most, is something that you've learned before in geometry, SOHCAHTOA. What does that stand for? Well, it stands for sine, cosine, and tangent. Sine is the opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Well, we need to know then what is the opposite, what is the adjacent, and what is the hypotenuse. Some of you might want to remember this. It'll be easy to remember if you remember this little saying. Some old hippie caught another hippie tripping over apples. Some of you might think of something else, tripping on something, but I'm not going to use that. Tripping over apples. All right, this little symbol right here is known as, is the Greek letter theta. And across from theta, that side is known as the opposite side. And right next to theta is known as the adjacent side. And always across from the right angle is known as the hypotenuse. So, the sine, we labeled these, the sine is known again as the opposite over hypotenuse. And the sine, cosine, and tangent, those are just trig ratios. Ratio is just another, it's a fancy word for fraction. Cosine, adjacent over hypotenuse. Now, very important, the sine and cosine can never be larger than 1. The reason why that is true is because the hypotenuse is always the bigger side, so this fraction, the bigger number, is always on the bottom. And then the tangent, opposite over adjacent. All right, in trig, we spend a lot of time on these two special right triangles, the 45-45-90 right triangle and the 30-60-90 right triangle. Now, in a 45-45-90, these two angles are the same, because all the angles in the triangle add up to 180. I know that's 90, so these two are 45. If we label this side here x, this side also has to be x, because they're across from the 45s. They're exactly the same. And this hypotenuse in a 45-45-90 is x times the square root of 2. On this special triangle, this 30-60-90, this one's 60, this one's 90, this has to be their 30. And if we call this x, and we'll call that our shorter side, if that is x, then the hypotenuse, which is right here, is 2 times that shorter side. So this is the hypotenuse, always across from the right angle. And then the longer side, or longer leg, it's not the biggest one because the hypotenuse is always the biggest, is x, the shorter side, times the square root of 3. Now we can use that to answer some questions. Here, find the value of each trig ratio. Well, number one, what we want to do is label each side. This is asking for sine of c, so this is my opposite, this is my adjacent, and this is my hypotenuse. And sine is opposite over hypotenuse. So all I got to do is write these numbers down and reduce the fraction if possible. It's not possible to reduce that fraction. So I'm going to do this one, sine of c, and I label everything. Across from the right angle is the hypotenuse. Across from the angle they're asking for is opposite. And then this one would be the adjacent. And again, sine is opposite over hypotenuse. So it'd be 30 over 50. Now 30 over 50 can be reduced. Always reduce your fractions or your ratios. And like I said, it could never be larger than 1. And it won't be because the hypotenuse is always the biggest. You always put the bigger number on the bottom. it's going to be less than 1. Cosine of C is adjacent over hypotenuse. So if I label these, there's my adjacent, this is my opposite, this is my hypotenuse. All I got to do is write those numbers in there. Adjacent is 36. Hypotenuse is 39. They're both divisible by 3. So 12 over 13 is the cosine of that angle. This one, also cosine. Adjacent over hypotenuse. So if we label all of these, there's my hypotenuse across from the right angle. Across from the angle C is opposite, and the one right next to it is the adjacent. So that would be 8 over 17, which cannot be simplified. That's it. All right, then the tangent, if you have to look back, it could go on an index card. Opposite over adjacent. Well, here's my angle A. This one is opposite. This one's hypotenuse. This must be my adjacent, and it is. Opposite is 12 over 35. They have nothing in common, so that's it. This one, tangent of x, just always make sure you're using the correct angle. That's hypotenuse, this is opposite, and always label them. Tangent is opposite over adjacent. That'd be 36 over 27, and 9 divides into both of those. Now, the sine and cosine can never be larger than 1, but tangent can. All right, this down here, rationalizing a denominator, will help you with some of your homework. When we say rationalize the denominator, it's because we don't want a radical in the bottom of a fraction. So what we do is we multiply by a, in this case, a square root, so I get a perfect square on the bottom. Well, perfect square is 1, 4, 9. Well, 2 times 2 is 4. So if I multiply the bottom by the square root of 2, I have to multiply the top by the same thing because I don't have an equal sign. The only thing I can ever multiply by then is 1. And if you remember this, inside with inside, outside with outside, these two are inside. I can multiply them together. That's outside, that's inside. So all I can do is rewrite this as 3 times the square root of 2. On this problem, I'm going to write this down as the square root of 4. Next one I won't, because the square root of 4 is just 2. And always simplify if you can, but because that's inside a radical and that isn't, I can't do that. Here I'm going to multiply by the square root of 3 on the top and the bottom, because 3 times 3 is 9. So I'll get 5 times the square root of 3. Square root of 3 times the square root of 3, like I said, is the square root of 9, but the square root of 9 is 3. Those are your notes, but I want to do 2 of your homework problems, all right? So here's problem number 3. And on this problem, I see this is 45, 45, 90, even though this angle wasn't given. And I know that in the 45, 45, 90, you can look at the notes here, the 2 legs are the same and the hypotenuse is x times the square root of 2. So if this represents the hypotenuse, then equals x times the square root of 2, well then I can just set the hypotenuse, which is 19, equal to x times the square root of 2 and solve this problem. So I'm going to divide both sides by the square root of 2. But we just learned you can't have a radical in the bottom. So I'm going to multiply by the square root of 2 on the top and the bottom. So I get 19 times the square root of 2 over 2. Now, because this is a 45, 45, 90, the x and the y are exactly the same values. So they were both 19 times the square root of 2 over 2. This one is a 30, 60, 90. So if that's 30, this one has to be 60. And in a 30, 60, 90, again, the shorter leg is x. The hypotenuse is twice that. And the longer side is that shorter side times the square root of 3. Here I know the hypotenuse, and I know the hypotenuse is equal to 2 times the shorter leg, and the shorter leg is x. I can replace the hypotenuse with 32, divide by 2, x is going to equal 16. Just be careful, they might switch these and put that y and that x. This side is the shorter side no matter what letter they use. So in this case, x is 16. And I know the longer side is equal to the shorter side times the square root of 3. But I know the shorter side, it's 16. There's nothing there to solve, so 16 times the square root of 3. Hopefully that will help you get through your homework. I just did 2 of your problems. Have a wonderful day.